Okay, so we're going to be rationalizing denominators. So rationalizing denominators means that you cannot have a denominator or a radical in the denominator. So when it means that you can't have a radical in the denominator, so say you had 5 over radical 10. So this right here, 5 over radical 10, that's a no. So that's a no-no. Okay, so the way to avoid that is to rationalize the denominator. In our first example, we're going to say we have 5 over radical 10. So since we're using 5 over radical 10, what you want to do is you want to take radical 10 and multiply it times itself. Again, it's only in the denominator. So it's only in the denominator. So when you multiply going across. So you're going to have 5 radical 10 because these cannot be combined. And then you're going to say radical 10 times radical 10. So then I get 5 radical 10. And this is like saying 10 times 10, which is 100, which also gives you 10. So then you're going to say 10. So your 5 stayed. And the only thing you changed was radical 10 times radical 10 equals 10. And then you cannot combine them, so you just add the radical 10 right there. So this would be your solution. Okay. Here's another example. We also have it where we have a entire term underneath the square root. So when this is the case, let's pretend we had radical 3 over radical 2. So the only radical that we have right here that we need to get rid of is going to be the radical 2. So then I'm going to take the radical 2, let's make it pink again, and I'm going to say, okay, radical 2 times radical 2. When we multiply going across. But what the difference is because these have the same index or the same root, we can now say radical 3 times radical 2 over radical 2 times radical 2. And it was radical 3 times radical 2. So because they have the same index, and I'll highlight the index for you. The index is the same, so that means you can combine them. So then from here, we're going to say that we have radical 6 over 2. This right here is its term on its own, so this is already in lowest terms. And this is our solution. So that was example 2. Okay, in example 3, we're going to reduce and rationalize. So if we're going to reduce and rationalize, say you had 10 over 2 radical 5. So what we want to reduce here is going to be this fraction of 10 halves. So as we're reducing, we're going to say, so the first step we're going to do is reduce. And we're going to look at our 10 halves, and we're going to say that's 5 over radical 5. And then the second thing we're going to do is we're going to rationalize. So we're going to say 5 over radical 5 times radical 5 times radical 5. So you're going to say 5 radical 5 over 5. And then if you look at it one more time, you can reduce again. So as I reduce again, you're going to say 5 over 5. Well, that just equals 1. So my solution is going to be radical 5. Okay, so let's go ahead and look at the worksheet. The worksheet in particular, these, you're just looking at the triangle and you're building the ratio. So if I look at cotangent, I have adjacent over opposite. So my adjacent is always going to be like right next to the theta. So this will be my adjacent. And then my other side is going to be the opposite. And then of course, you always need to find your hypotenuse, and my hypotenuse will be the diagonal. So if I say adjacent over opposite, this is going to be 4 over 3. And everything needs to be in fractions. Okay, so let's look at number 6. It says if cotangent of theta, or find cotangent theta if secant of theta equals 2. So let's just write this down. I'm finding cotangent of theta. And then I know that secant theta equals 2 over 1, or because it's a whole number. So now I'm just going to build my triangle. We know it's a right triangle, and secant is going to be hypotenuse over adjacent. So let's go ahead and just write this underneath or next to it. Hypotenuse over adjacent. So I know that 2 is my hypotenuse, and I know that 1 is my adjacent side. So my hypotenuse is 2, my adjacent side is 1. That means that theta is right here, and then I need to know what my opposite side is. Because since we're looking for cotangent, we need to remember that cotangent is going to be adjacent over opposite. This is number 6. So from here, we're going to use Pythagorean theorem to find the opposite side. So we're looking for this side right here, which is the opposite side. So we're going to say, it doesn't matter what A or B is, so we say this is A, this is B, and this is C. So I know that A equals some unknown, B equals 1, and C equals 2. Again, we're using A squared plus B squared equals C squared. So A squared we don't know, plus 1 squared equals 2 squared. We're going to say A squared plus 1 equals 4. A squared plus 1 equals 4. We're going to try and isolate this right here. Subtract 1 from both sides. 3 equals A squared. I want A because I just want 1A, not A squared. So you're going to take the square root. Taking the square root of both sides. So a equals the square root of 3. You're going to leave the radical. Okay, there are no decimals in this. So go back to our triangle. We know that this side is going to be the square root of 3. And we know we want cotangent, which is going to be adjacent over opposite. So let's go with what we want. We want cotangent of theta, which is adjacent over opposite. So I'm going to say, again, my adjacent is square root of 3. Oh no, that's my opposite. So my adjacent is 1. So I'm going to have 1 over square root of 3. I cannot have the square root of 3 like that. So you're going to say 1 over the square root of 3 times the square root of 3 times the square root of 3 equals square root of 3 over 3. And so cotangent of theta equals square root of 3 over 3. This is my solution.